linear equations. Before we get into that, a few announcements. Okay, so today we're starting Unit 4. Unit 4. Last day of school before winter holiday is next week, Wednesday the 15th. That's next week, Wednesday. Okay, and then if you have not finished Unit 3, I want you to have it completed by next week, Wednesday. So we are juggling two things at once here. We're finishing up old stuff from Unit 3 for those of us who still need to finish stuff in there. And we're going to be doing Unit 4 at the same time. So every day in class, Unit 4 stuff. Want you to do after class, do at least one item from Unit 3. Retest on your next mastery test. If you need a refresher, go through the tutorial to see how it's done. And then refresh again on the mastery test. Try one a day, and I guarantee you, you will be caught up. Come to my Tuesday extra appointment times, and I can give you extra tutoring Tuesday at 3 o'clock. Also, by the way, I have an extra hour now opened up in the morning right before this class. So 10 o'clock, um, meet with me Tuesdays at 3 o'clock for extra help. Or also, you all are welcome to come at 10 a.m. Monday through Thursday. So you can join me tomorrow, Wednesday, and Thursday at 10 o'clock to get extra help on wherever you left off previously, or on Unit 4 stuff. Okay, we can work on all of it together. By the way, I'll be using like breakout rooms, so it'll just be you and reworking on an assignment. I will go in a circle and check in with you if you join me for extra help during these hours. Okay, and then also Brandon. So I know I've been telling you about this the whole semester, but I want you to contact Brandon for extra math support as well. Here's his email. He's our math intervention specialist. And so he's our math tutor who's here to help you throughout the week. So you've got extra time with me available in the mornings, 10 o'clock. That's just for this and next week. When we start back the semester after Christmas break or winter holiday, then that 10 o'clock is going to go away, unfortunately. But for this week and next week, I can help you guys extra at 10 o'clock in the morning. All right, a few more folks joined. Let's see. Good morning, Brooke. And good morning, Savannah. Good to have you back. All right, get your paper ready. I want to have some notes today, but also I'm going to be asking you all to answer some questions in the chat. So, low pressure. In the chat, I want some participation with answering some questions today. So, let's see how this goes. All right. Warm up question number 1. I've got a graph on the screen of a point, just a single coordinate. Examine that graphed point. What is the coordinate of the point? That's the question. What is the coordinate of the graphed red point? Now, here's what I want you to do. Type your answer in the chat, and remember, the coordinate is going to be like this. It's like two numbers, x and a y, in parentheses. That's how we type our coordinates or our points. I want you to type your answer in the chat, but don't hit enter yet. I want you to just wait to hit enter until I count to 3. So we'll see everyone's at the same time. Now, here's one more thing. If you don't want everyone to see your solution, your idea, then you can actually change it to go just to me. Let me show you what it looks like. Here we go. So in the chat, I think you guys should be able to see this. You can change if this goes to everyone in the meeting or just Josiah, or like, I think it'll say my name, Josiah Henderson. So that's cool too. If you want to change it to just chat to me, that's all good. But at the count of three, I want to see everyone's best idea, best guess that you can take on what is the coordinate of the point. Okay, if there's no questions, are there any questions? Then we'll do this thing. So I'm going to count to three. 1, 2, 3, go. All right, I've got one message in, two messages in, plus I think someone did one before, so that's three. Come on, let's get the rest of you. One, two, three, four, five. Let's see. Yeah, it should be five of you. Okay, so I see Savannah, Levi, and Anaya. Awesome. So Brooke and Moose. Brooke and Moose. Brooke, awesome. Thank you. And I think I saw Moose as well. Awesome. All right, that's everybody. Thanks to all five of you for answering. Let's just really quick go over it. I saw a lot of the right numbers. Let's double check. And you know what? I'm not even going to like look at your answers right now. I just want you to engage with it and try it out. So a lot of you are using the right values. Let's just check and see which place they go in. Remember, it's always the X first and then the Y number. And then it's like, well, okay, so which is which? X is the horizontal. So this left, right direction. And then Y, the second number that we write, that's our up, down direction. So with that in mind, we're always kind of starting right here where the lines cross at the origin. So from there, we look at our rulers. The X distance is here, 4. And then how high is the point from there? 2. So we would write it as 4 comma 2. 4 to the right, up 2. Things get a little weirder when we're in the negative zones, but it's the same process. So let's look at a negative example next, okay? Get ready. Here's a new one. Same prompt. It's a purple point this time. I want you to examine the point, do your best to label or write the coordinate for this point, and we'll do it in the chat again. Here it is. It should be a number, comma, a number. We're doing the left distance first, and then the height, up or down. I'm going to count to 3, and then let's see your ideas, your solutions come in the chat, okay? 1, 2, 3, go. Good, there's 1. Doesn't have to be right. I just want to see you try. What would you say? Great. There's another one. Thank you. Should have 2 more. Waiting on 2 more folks. So we can use the ruler below and to the side, right? Now, on the last problem, I'm going to go back quick. On the last problem, our red point was in the first quadrant. So we were looking down and to the left. But regardless of where the point is, we're going to look towards those axes, the X and the Y lines in the middle. Those are the rulers, the axes. So let's see how many spaces, how far over is the purple point this time? From 0, 5 squares over, but it's in the negative direction. So we would say its coordinate is -5. And then how high is it? From the purple point straight down to that line, it's 3 high And note if you look at the ruler, it's actually in the positive zone, right? So it's going to be positive 3. So -5, positive 3.
Um,
Yeah,
Josiah,
please.
I just realized that I entered mine backwards.
Ah,
I got confused with the X and the Y point, but I would change it to -5, 3,
for
and
sure.
then the last one would be 4, 2.
Very good, Levi. Thank you. Awesome. Yeah, that's why I wanted to warm up with these because it's easy for all of us to mix them up. So I appreciate you letting me know and for engaging and trying it. I want to try one more with you guys that is going to be harder. So warning, it's a little harder. Warm up question 3. Examine this black point I made. We're going to estimate the coordinate of the point. It's supposed to not be a question mark. Estimate means we can't know for sure what the coordinate is, but I want you to take your best guess. We can use decimals and we can use fractions. But the question is, how far leftwards or rightwards is this black point? So here's a kind of a hint. It's like how far this way, and then how far up does it look like it's reaching compared to its ruler? So I guarantee you everyone's going to have a slightly different answer for this, and that's okay. That's the point. We need to just do our best to estimate the coordinate. I don't even know the actual answer. I just want to compare notes. So in this one, I do want to share everybody's ideas, if that's okay. No big deal, because we're all going to have something different. And I'll tell you what, I'll even go first. No, I won't. I'm going to go last. I don't want to poison the well with my ideas. I want to hear from you first. So, do your best to estimate the coordinate of this one. Remember, and like Levi just pointed out, it's the left right x number first and the y height number second. If you mix them up, no big deal. But let's just practice that order, okay? Here we go. I'm going to count to 3 and then put your number in the chat for me, okay? Your coordinate. 1, 2, 3, go. All right, let me check and see what's going on. Okay, I'm not getting any new ones. Folks, do your best to estimate it. They're not gonna be perfect, and they're not gonna be the same as your neighbors or mine, because we really don't have enough information to know for sure, but we can estimate it. We can give a ballpark, rough idea estimate of what the coordinate is for that black point. Okay. Anaya for the win with a great suggestion. Thank you. Let's hear from the rest of you. What's your estimation for the coordinate of that point? And Tira, thank you for the idea. Levi on point with a great suggestion. Keep going. Thank you, 3. I want to hear from the rest of you. Should be at least, what, 3 more of you? Everything I've seen you say so far, those 3 of you, Tira, Levi, and Aya, I think they're all great estimations. Savannah, Moose, and Brooke, any suggestions, any ideas from you, please? What would your estimation be here? Okay, I see one more came in. Thank you. Brooke, nice. Good. Good idea. I like it. All right, Moose and Savannah. Are you two still with me? Okay. Well, for the four of you who answered, let's check those answers out. All right. And you're all like really close to each other. So one idea was 2 comma 2, then 2.5. Maybe for both of them, like for 2.5 comma 2.5, something like that. I'm just interpreting that. And then 2 comma a half. And then the last one I saw was 2.5. Great. It's possible that I misinterpreted some of your guys' ideas. So forgive me if I did. But this is actually what I would say too. I would say it looks like, let me change my color up here and we'll examine this a little closer. And then we'll start looking at systems of equations. So in purple, remember for the x number, the first number, we want how far is it from our black line to the right till we get to the point. So I'm basically saying how long is this? To find out, we look down to that ruler below. And it's roughly it's like one here and then here's 2. So it's almost to 2. So it looks like it's bigger than 1.5 and but not quite to 2. So I think a good guess for x would be somewhere like 2 or I'm sorry, 1.5 would be okay, 1.6, 1.7, 1.8 because it's hard to tell, right? We can't really tell if that's maybe even 1.9. Somewhere in that neighborhood is about how far the black point is left right wise. Now we've got to examine it up and down. And this is where I think you're all getting that 2.5 from. I imagine. It looks like it's about 2.5. Let's change our color quick to green. So the height, how high is this thing looking to its ruler? Yeah, it's about at 2.5. Yeah, right on point for what all of you were saying. So its height is probably around 2.5, maybe 2.6. And its left right, I think, could be any of these. And honestly, if this was like a quiz and someone said 1.5, 1.5, I think that would be acceptable too. Everything in that range is likely for that black point. I've drawn on it a lot here. So I hope you can still see it. Any questions or comments on this third question before we move on and look at systems today? I'm going to open up the cameras again quick just to see. There's no chats, no one looking for help in the cameras. Okay. Well, thank you all for trying that with me. I really appreciate your feedback. We are going to be doing some more, so get ready, some more estimating today, where we can't tell for certain where a location is, but we're going to do our best to estimate that distance or that height, just like we did with this point. Okay, so let's look at what the point of Unit 4 is in total now. Systems of equations. So this is probably new. A lot of the stuff we've done in class these last few months and weeks, you've seen before in other math classes. But systems, I think is probably new for the first time today. So systems of equations. Have you heard the word system used before in life in a non-mathy way? What does it mean to you? Take a moment and think about the word system and what does it describe to you? What does it mean to you in a non-math class context? Any ideas, any thoughts? Anyone willing to share your ideas on the word system?
Um, for me, a system means like, I mean, I guess it would kind of be in like a community type way, but or a support system.
Totally.
Um, so like, I mean, I think all systems are like systems that support everything around it.
Absolutely. I like that word too. Everything around it. So it's like the word everything, Levi, to me suggests more than one thing at once, right? It would be you and me and your other teacher and, your friends. And then all together, that's a community. That's everything. That's a support system, right? Is that okay?
Yeah.
Yeah, it's like a big group. And then, I mean, not all big groups are supporting, but when they are, then it's a good system. Um, and I think the key there is that it's like many different people or many different things kind of all working together. I see something in the chat too. Levi, thank you for sharing. And Anaya said, I read a lot of books. I think of system, I think societies and how they run. Totally. I'm going to add that to this list of ideas. Societies run like a system. Absolutely. Like, for instance, how does a society run like a system? I think, and Anaya, jump in if you want to add to this, but I think a society is like a system. Like we've got the education system, right? We all are basically forced to go to school, right? But then it's for everyone's betterment, and then after that, there's work, there's college, there's the military. There's so many different things that we do after our system of going into school, and then there's the economy, right? You hear talking about in the news all the time, the economy and gas prices, and it's all interconnected in one giant system. Another example I think of, which some of you are probably dealing with too now, is cars. Like the inside of an engine is a system also. I'm gonna just throw that one in there, car engine, because there's like a million different parts, right, in a car engine, and it's super confusing if you don't know anything about it. Um, I don't know how the entire engine works together, but I know about lots of the different little parts and their specific job. The point is, just like Levi said with the support system in a community, and Anaya said with the societies, like one big system, and I would humbly suggest also a car engine, they're all made of like many pieces that kind of go together to make a bigger whole. So, with that all in mind, a system of equations is basically the same thing, but in a mathy way. A system of equations is two or more equations at a time, graphed together. So far, we've only been dealing with one equation at a time. So when you hear the term system in math or system of equations, it's just code, fancy code for we're doing two or more equations at once. Now, because there's two equations at once, it's a little more interesting. We get some different things happening because we've got more than one line or function at a time. So, taking notes, make sure to write this down or something like it, that a system means two or more equations at the same time or graphed together.
So, Josiah,
Yes, please.
um, so I'm just gonna take a picture for now since I don't have my notebook or a pencil. And then
What?
later, I can write it down like off the picture, like copying it off my phone.
Tira, thank you for telling me. Do that so you have something to use for later, okay?
All right.
A solid plan. And maybe because we talked about it, engaged with a little bit, we won't even need a note. I mean, I still want you guys to have your notes, but I think the more we engage with this stuff, the little more it makes sense, and the more likely we'll be to memorize it anyways. But I'm rambling. Okay, so let's look at a little more of this. So if you do have paper, I want you to just practice this exercise with me real quick. On a piece of paper, draw two straight lines that cross each other. Make it look however you want. All I'm asking is that we've got two straight lines and somewhere they cross. Another note, if they're not perfectly straight, it's okay. Just try your best to make them look straightish. And then if you can do that, show me in your camera real quick. I'm assuming we're all going to have a slightly different sketch. That's what I was hoping for. But the one thing they'll have in common is that it's two lines crossing somewhere. And another quick thing I want to mention, you don't have to make it perfect with like the X and Y coordinate. Just what does it look like to you when you hear two lines crossing? Levi's got something awesome. Perfect, Levi. Love it. Thank you. All right. How about the rest of you? Can I just see real quick what you have? Savannah, Anaya. Legit, Anaya. Thank you. Very good. Moose, I know sometimes we have issues with the camera, but if it works, I'd like you to just show me real quick your version of two lines crossing. And Savannah, you too. And Brooke, are you there, Brooke? Let's see your two lines crossing.
Josiah, may I tell you, since I don't have a pen or paper?
Tira, for the win, a verbal description. Give it to me.
I just figured when I think of two lines, I think of like almost kind of like a cross, maybe.
I'm going to make it a traditional cross, just like you described. This will be ours, Tira.
Yeah.
Two lines crossing. My lines aren't perfectly straight, but it's pretty close. And that's all I was hoping to see from you folks. Thank you. Oh, Moose. Thank you, Moose. I see that. And Savannah, I got yours as well. Very good. Thank you to you folks for showing me, and Tira for scribing that out for me. So here's my question. With our two lines crossing, and we all have slightly different lines, right? Assuming our lines are straight and they're not like curved, like here's a curved line, right? Obviously turning around. So assuming we don't have lines like that, how many times should our two lines be crossing each other? How many times do they cross or intersect? If you have an idea, throw it out there. Type it in the chat or just tell me. How many times are these two lines crossing?
Just once, actually.
Just once, right? They can't cross more. Oh, someone in the chat. They can't cross, thank you, Moose, more than once if they're straight lines, right? Exactly. Now, I know you might be thinking that's an annoying question, maybe, because it's like, duh, Josiah, but I wanted us to think about that and be very conscious of it. If our two lines are straight lines, which when we're dealing with these kinds of functions, remember y equals mx plus b, when we're dealing with our functions, they're always going to be straight lines. So in this new world of systems of equations, here's my main takeaway. The solution to a system of equations is the point, the one coordinate where they intersect each other, where they cross. I'm going to leave this up for a moment. This is our main takeaway. When we're looking for a quote unquote answer or solution to a system of equations, if we're told to solve the system, what they mean is, where do they cross? What point, x comma y, are the two lines crossing? So sometimes this won't be too hard of a question because we're just looking at the graph and saying, okay, I can see they're crossing right here at 4 comma 3. And that's the solution. Later, tomorrow and Wednesday, we're going to look at how to solve a system without the picture. Today, we're going to focus on when it's graphed, and we're going to focus also on estimating it, even if we can't tell for certain, but we can get the best idea, the best answer possible as to where the two lines are crossing. Okay, let's look at another practice question. I hope this is big enough. If it's not, give me a shout and I will try to zoom it in. Examine these two crossing lines. I've got a purple and a green line this time. What is the solution of the system? The purple and the green line together is the system of equations, a fancy way to say we've got two lines crossing. The solution is code for where are they crossing? What is the one point that lives on both the lines? And I'm going to go ahead and make a circle on it, a point on it. Cool. I see one answer coming in the chat. Take a guess at this. Take your best guess at this. Unless it's too zoomed out, in which case I apologize, and I think the rest of them should be a little bigger. It's just like what we were doing earlier, except we've got the two lines this time. And the truth is, we're only really interested in where they are crossing. Okay, I see one answer in the chat. Let's see. Anaya, thank you. Atira, awesome. Let's check that out. You both said 2, 6, so let's check it. Remember, x is the left right. So looking down, comparing my point, my green dot, to like the ruler below it, how far to the right from 0 is it? It's over 2. So it's 2. How high is the green dot? It's up 6. Awesome. So 2 comma 6. So to you two who answered, awesome. Thank you. And Levi as well. So we don't even know what the equations are for the purple and the green line, but we know the solution. The solution is 2 comma 6. Let's try another one. I'm going to change my color. I think that's kind of hard to see. Okay, so here I've got a green line and a black line. Same game. What is the solution of the system? Let's do our best to find that answer. When it's on a whole number, we can ideally find the actual solution, like the final solution for it. If it's not on the whole numbers, then we're going to be estimating, like we saw in the warm-up earlier. So take a moment, see if you can find where those two lines are crossing. We're looking for an X and a Y. Cool, I see 2 answers coming in. Anyone else? Get your answer in. I'm going to compare them. Cool, there's 4 in. Awesome. Anyone else? Should be 2 more. Now, it's okay if we don't all have the same answer. It can be tricky when we're dealing with the negatives, but I like to just focus on the part I'm interested in, right? The crossing point. And then I can see where that correlates to on the 2 rulers, right? So looking one way, I've got this 2. Looking the other way down, I've got this -4. So those are our 2 numbers of interest, 2 and -4. And then it's like, which is which, right? Which one is the height? Which one is the left right? Well, the horizontal ruler is the x ruler. So that means my -4 would be the x number. My +2 would be the height number. So if you can just look to both rulers and identify both numbers that it kind of goes with, then you can wonder or ask yourself, secondly, which one is left, right, X, which one is up, down, Y. That might be a good approach to use. Thank you to all 6 of you for answering. Nice job. Thank you, everybody. Cool. So let's try one more now where we have to estimate it, okay? Just like in the practice earlier. purple and red lines. What is the solution? Estimate the solution to the best of your ability. We can use decimals, we can use fractions to get that like partial distance for its height and its left rightness. And just remember, everyone's going to have a slightly different answer for this, and that's okay. We're just practicing eyeballing it, estimating it to the best of our ability. I see one answer came in. Thank you. 2. Awesome. Yeah, I didn't count to 3. I'm sorry, I kind of did break that little rule of mine. My bad. I should have thought this through myself. I didn't want to pressure people for a question like this. I want you to take your time. So if you do have a solution, please put it in the chat. I want to hear from all of you. 4, thank you. 4 of you who answered. If you're waiting for me, I apologize. Go ahead and put it in now. And then we'll just quickly compare notes. Let's practice doing it the way I was trying it for the last example. You see the red point, and we're trying to just find its x and y, its coordinate. So I look down to the first ruler. I look down to the left-right ruler. Okay, it's about right here, right? It's about right there. I might have messed it up a little while I was looking down, but it's pretty close to that arrow. So where would you say that is? Is that bigger than 6.5? It looks a little bit bigger than 6.5 to me. So maybe I say this is 6.6 or 6.7. I think either of those would be good. Even if you said 6.5, 6.5, I think that's okay too. Those are all reasonable guesses for how far to the right that is. Now let's look and see how high it is. So we scan towards the Y ruler. You know, a little bit, it's not perfect, but I'm doing my best. And then there's my arrow. So how high is that? It's past the 2, but it didn't reach the 3, right? Again, it looks like it's probably higher than 2.5, which would be right in the middle. Right there would be 2.5. So maybe this is 2.7 or 2.8, somewhere in that neighborhood. So that's how I approach the estimating. It's okay if we don't all get the same answer. Now, I want to look at some multiple choice ones from Edmentum, where if we can rule out some of the options and just choose the best one that they give us, then we're doing a good job of estimating. You know, if we can rule out the ones that are obviously wrong with negatives, if it's supposed to be positive and stuff like that. Okay, before we move on, any questions or concerns?
No.
Thank you, Tira. Okay. All right, well, let's move on. Let's try some more.
Josiah.
Yeah, Levi.
So this doesn't really have anything to do with the problem,
Okay.
but I just started taking my ADHD medication again,
Okay.
and I'm feeling a little bit shaky. So I just wanted to let you know that.
Okay. Thanks for telling me. Are you feeling like you need to take a break? Is anyone there with you?
No, yeah, I have my grandparents here with me, but I'm fine.
For sure. Okay. Well, let me know if I can help, and if you need to take a break from me, that's fine. I won't like hold it against you if you disappear for a little bit. Okay.
Okay.
All right. Just let me know, Levi. Thank you. All right. We're almost done with today. There's just a couple more ideas I wanted to throw out there. So earlier I had you guys draw your crossing lines, and we were all on the same page that if they're straight lines, you know, they're only going to cross once. And this is mostly the world we're going to be living in for this whole unit, mostly. However, what if we have two lines that are parallel? Remember what parallel lines mean? So here's two lines that I already drew that cross, right? How about parallel lines? Well, they go in the same direction, like this. Now, again, we're assuming that we're working with straight lines that aren't like purposefully bent. So if my two lines are parallel and they never cross each other, what would you say about their solution, quote unquote? Remember, the solution for a system is where they cross. So if two lines exist, but they don't cross, the best we can say for their solution is there is no solution. Parallel lines have no solution. They don't cross. And because the crossing point, the crossing coordinate is the solution, therefore it doesn't exist. So you could say no solution or solution doesn't exist or something like that. Now, most lines that we deal with will cross, right? But parallel lines exist, so we have to be ready to talk about those if we ever are presented with them. By the way, remember slope from Unit 3. Slope describes how steep a line is. So if I've got two parallel lines like these two I drew here already, up and over, the same amount up and over, that's the slope. Two parallel lines are moving up and over the same amount. They have same slopes. So just a side note, we're not going to need this today, but it'll come in handy to know and to think about. If two functions have the same slope, that means they're parallel lines. And that means they have no solution as a system. This will come into play tomorrow, I think, a little more, but just to think about it ahead of time. Two functions with the same slope, that means the lines that they make would be parallel, and that means also they don't have a solution as a system of equations. Okay, one more special case. We looked at the parallel lines. Now, here's an example of kind of the opposite nature. So you can have a case where two functions are actually identical. What if two functions are identical to each other? Here we have y equals x plus 4 and 2y equals 2x plus 8. I'm going to come right back to this, but I want to show you something just to do it fast. I have it on my computer. So here's those two functions, x plus 4 and 2y equals 2x plus 8. So here's the red one, y equals x plus 4. And if we graph the second one together with it, it's right on top of it. I'm turning it off and on in purple there. 2y equals 2x plus 8. These are actually the same function. They don't look like it in their equations right now. But they are the same function. And how we could figure out that they're the same function or equation is look at the 2y equals 2x plus 8 with me. If we were to divide both sides of this by 2, all parts get divided by 2, then what's left? 2 over 2 is 1, so we have y equals x. 8 over 2 is 4. So a little bit of algebra, and then we see, oh, snap, these are actually the same function. One's just been doubled, where all parts have been multiplied by 2. Now, if we graph those, like we saw in the picture a second ago, they're actually right on top of each other. It's like the same line, just kind of stated in a different way. So we graph the first one and we get the red line. We graph the second one and we get the purple line, and they are essentially the same line. Technically, we had 2 different equations, right? So we have a system here. But because they intersect at all their points, because they're like laying right on top of the other one, then we say they have infinite solutions. Every single point on the red is on the purple. They are complete and utter match. So those are 2 special cases. The parallel lines that never cross, no solutions, and the identical lines, identical functions that intersect at all points. So they have infinite. That means it goes on forever. Here's the symbol for infinite. Infinite solutions. Now, I hate to drop word problems into this all of a sudden, but some of the problems in the mastery test are word problems. I wanted to model doing some of these with you quick. Once you start doing them, once you get the hang of it, I think it won't be as bad, even though word problems I know can be hard to navigate. And the bigger the numbers, like these ones look like, the more confusing it gets. So let's do some of these together quick. Just to see what they are like, okay? So these are straight out of the mastery test for today, so you might see them later. A company sells 2 versions of an antivirus software. Okay, the home edition costs $23.50, and the business edition costs $58.75. Last week, the company earned this much money, $29,000 and change, from selling 745 copies of the software. Now, don't look at the next sentence yet, okay? Just looking at the first sentence that I marked up in purple. When we're writing a system of equations from word problems, we're always going to be writing here, let me write this down. We're going to need to write 2 equations. We know that there'll be 2 because it's a system. So we want our goal is to write 2 equations. They're both going to have X and Y in them. X will stand for one item from the story, and Y will stand for the other item in the story. X and Y stand for 2 different items. In the story. So help me out with this. The first 2 sentences up here in purple that I marked up in purple. Any ideas, any thoughts, any initial thoughts from you guys on what the 2 items could be in this case? 2 items from this story about antivirus software.
Just like anything that could be important to the story.
Yeah, totally. Does anything pop out to you as probably being important, and they're like separate but comparable 2 different items that as they're presented to us?
Maybe the costs.
Yes.
The home edition and the business edition.
Bingo. Yeah. If our goal is to find these 2 special items from the story, that's exactly what I was thinking too. The costs of these 2 different editions. There's the home, number 1 item, and the business is number 2 item. And the story gave us prices for each one of those too. $23.50 and $58.75. So one of these is going to be X and the other will be Y. Honestly, it doesn't matter which one we pick to be X or Y. So if we're doing multiple choice stuff in Edmentum, they're going to pick one to be X and one Y. If you and I were doing this together in the room, like in a regular class, right, non-Zoom, you could pick either one, and I would be able to see what you mean. But we need to be flexible, knowing that Edmentum may pick the opposite of what you pick. So here's what I mean. Let's say home edition is X, business edition is Y. Why did I assign them X and Y? Because that's the order they presented them to us, right? The first thing they give us is usually what I'm going to make X. So I'm going to say X times 2350. Plus Y times its price for the business edition. Y times 5875. Now here's another question. Anaya just said the costs of home and the cost of business. Do we see another information, any other value that has to do with costs or money in this word problem? A third number that has to do with money or costs. Anybody?
The the money that the company earned.
Yes, 100% correct. They said later that the company earned this money, this amount, this dollar amount, 29,000, blah, 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 668.75. The point is, the first equation you make is going to all be money, all related to the same thing. So this is a dollar amount, this is a dollar amount, and then it all equals a dollar amount. Let's see here, 29,668.75. Now, if we knew, let me fix this dollar sign I made. If we knew how many home editions and how many business editions this company sold, we could plug those in for X and for Y, right? If they sold 15 home editions, I'd plug it in for X. And if they sold a certain number of business editions, I could plug it in for Y. You would multiply by the cost, the 2350 and the 5875. You would add, and then it would equal the total amount the company made. So our first equation is this, what I have written. It's all relating money. Our second equation below is going to not take in any of the money into account, but X still has to be home edition and Y still has to be business edition. If I add up how many they sold, it says in the story they sold a total of home plus business 745, 700 right up here, and 45. So X plus Y is equal to 745. The second equation I made has nothing to do with money, and it's just copies sold. Notice that there's no money involved, right? We didn't put the 2350, the 5875, or the 29,000 number in there. It's just like how many units went out the door. If it was actually in a store. If it was online, how many codes were sold, right? But when we're trying to like make equations from a word problem, make sure that you're kind of putting the right numbers together that mean the same thing. So the first one has to do with all money. The second one is just copies sold of home edition and business edition. Now, then we could like kind of look through the options and find the best one. So if we kind of pick apart A, B, C, and D, I'm sure what we would see is they're mixing together the wrong numbers. So really quick, let's look at A as a potential answer. So I look at option A up here, and it's got money times X and then money times Y, but then it equals copies sold. That doesn't make sense. That's a mixing of our variables. That doesn't that like can't go together, you know? So that's a red flag. Like, uh-oh, this is a problem because it's got a dollar amount plus the dollar amount equals copies sold. So if we could switch these, that would be good. That would be golden. So if we look below, we find one where they actually are switched. It's 12, so I need to let you go. The homework is to try doing the very first mastery test in Systems of Equations, Unit 4. Okay? I want you all to try that today. Do your best. And I think tomorrow we're going to do a little bit of practicing it together, and then we're going to look at the next section, the next lesson together. I did record this, so I'll put it up on YouTube in case anyone wants to look at it again. You've also got the tutorial you can look at for extra support as well. So bye, Savannah. Thank you all for working on these questions with me today. I really appreciate the feedback.